Hey guys, this is your chance to see the solutions to the mid-chapter quiz. So find the problems that you had trouble with and review these solutions with me. The first set is 1 through 3, and let's start out with number 1. We're supposed to use this figure to name another point that's collinear with points U and V. So remember that collinear means points on the same line. So points U and V lie on this line that is running vertical on our diagram. What other point is on that line, collinear with those? That would be point P, the only one that's identified on that line. Number 2, what's another name for plane Y? Plane Y is labeled here in the corner as our blue vertical plane. What's another name for that? Well, remember, you can name a plane by just naming 3 points you can find on the plane as long as those points are non-collinear. So they must be in a triangular type of pattern. There are 3 points on that plane labeled T, R, and S. So let's name that plane that way. Let's call it plane TRS. And of course, the order you name those in does not matter. Number 3 is to name a line coplanar with points P, Q, and W. Coplanar is together on the same plane. We find points P, Q, and W lying in the green plane. What's another line that's in that same plane? This line right here extends forever along with the plane, and so this line is in the same plane. Let's call that line RS. Using our line symbol, double arrow, line RS, or of course line SR. Numbers 4 and 5. Find the value of x and the distance from A to C if point B is between points A and C. Of course we're going to need a picture. Let's diagram this out. We have 3 points. Let's draw the segment, and point B lies between points A and C, which means A and C are our endpoints, and point B is somewhere in between on that same segment. We know that number 4, the distance from A to B is 12, and the distance from B to C is given to us as 8x minus 2. All the way across from A to C, they tell us is 10x. So we need to set up an equation to show this relationship. Let's write it as the distance from A to B, which is 12, and combine that, add it to the distance from B to C, or 8x minus 2, set equal to 10x, the full length. As we solve this equation, we're going to put x's on one side and simplify. Let's simplify first. We're going to take the 12 and the negative 2, combine those to make a 10, and bring down the 8x, and let's bring down the 10x. Now, to get the x's together, let's subtract the 8x's from the left side and the right side, and that gives us 10 on the left and 2x on the right. So reducing to get 1x, divide by 2 both sides, x is 5. We also were asked to find the distance from A to C, so let's be sure to plug that in. From A to C, we were given that to be the 10 times x. So let's make that 10 times 5 for a total distance of 50 units. So here's our 2 answers. X is 5, and the distance from A to C is 50. Let's do number 5 now. It's the same situation. We still have that drawing, so let's redraw it with A and C as our endpoints and B in between. This time our information is that A to B is 5x, B to C is 9x minus 2, and all the way across is 11x plus 7.6. Make that a decimal. Same kind of setup. Let's add the 2 smaller portions together, or 5x, add that to 9x minus 2, and let that equal the total length all the way across, which was 11x plus 7.6. Now, our algebra tells us we need to simplify both sides. Let's combine our 5x's and our 9x's to make 14x. Bring down that negative 2, and let's bring everything down from the other side. Now let's combine x's on one side. Since most of them are here with a 14x, I'm going to subtract 11x's to take them off of this side. And I'm also going to try to move the 2 over to the other side. So by adding 2 on both sides, I can do that. There's a cancel there. So now we recombine the terms, which is going to be 3x's equal over here to 9.6. Then I just need to divide by 3 in order to reduce that. So the 3x's are now reduced down to 1x, and 1x is equal to 9.6 divided by 3, or 3.2. So 3.2 is the value of x, and then we're going to go ahead and plug in and find the value of the distance from A to C. We'll take 11 times the 3.2 and then add on 7.6. I'm going to open a calculator to do that. So 11 times 3.2 plus 7.6 gives me a total of 42.8 for the distance from A to C, 42.8. All right, moving on. Number 6. Find the distance from C to D and the coordinate of the midpoint of segment CD. The distance first. You'll remember the distance means we're going to take the two coordinates, which are in this case -9 and 5. We want to find their difference and absolute value that. So I'm going to subtract those, -9 minus 5, and wrap it in absolute value and calculate for that distance from C to D. And so -9 minus 5 gives me a -14. In absolute value, that's 14. The distance from C to D is 14. We are also asked to find the midpoint of CD. So the midpoint of CD was where we took the average of the two to find the center. So averaging -9 and 5 would mean take -9 plus 5, divide by 2. Finding that would give me -9 plus 5 gives me a -4, divided by 2, a total of -2. So the midpoint is located at -2, and check that on your graph. Next problem is number 12. We get to draw a picture of this. We need to find the kind of angle this is, but we definitely need a picture. So let's draw a grid, x and a y axis. We're told that the vertex of the angle ABC is located at the origin. The origin on a grid is where these two axes cross. So right here we find our vertex, and since B is in the middle, its name is point B. Point A is located at 5, 0. That means 5 on the x-axis and 0 on the y-axis. So we're going to stay right here, and this is going to be point A. And then finally, point C is located at 0, 2. That means we don't go over on the x-axis, but rather we go on the y-axis up to the level of 2. And this is our point C. So let me draw the angle in. We have it coming from B through C and from B through A. So these are the sides of the angle. What kind of angle is that? Well, of course we know that a vertical and a horizontal line make a right angle. This is a 90-degree angle right here. And so this is, of course, a right angle. Numbers 13 and 14 require us to draw this picture. So be sure you pause the video if you haven't already drawn the picture. In 13, we're told the measure of angle AXC. AXC is all of this bigger angle here. And we're told that that measure is 8x minus 7. AXB, this smaller angle, marked in red, that angle is 3x plus 10. Our question then asks us to find the measure of angle AXC. AXC was the one they gave us in purple, so we have to come up with that measure. We are also told in the directions that it was bisected. Angle AXC is bisected by the ray XB. So this ray XB is coming through and bisecting, and they've already marked that for us with the tick marks. So these two angles are congruent here. What does that mean for us? That means that we can write that 3x plus 10, we can also put it in the second spot where there was a match. So we have two angles that are 3x plus 10. Let's set up an equation. The 3x plus 10 angle added together with another 3x plus 10 angle, or you might just want to multiply by 2, equals the full angle from AXC. So that 8x minus 7 angle is the total. And then we do our algebra. Combining like terms gives me 6x, and 10 and 10 makes 20 on this side. And then we'll just bring down the 8x minus 7. Now let's get those x's together. Let's put the x's with the 8x side because that's where they are for the most part. So let's take away 6x's, and that gives me just 2x's. And let me go in the same step, let me go ahead and subtract the negative 7 off, or in other words, I'm going to add 7 to both sides so that I can cancel the 7's, and that makes this, bumps that up to 27. So last step would be to divide that by 2, and that gives us a decimal this time. So we're going to have the value of x is 27 divided by 2, or 13.5. So you can read that. Now we have to go back and plug this back in because we were asked to find the measure of the angle. So using the value of x being 13.5 in here, let's open up a calculator and let's calculate that. We want to take 8 times 13.5 and subtract the 7. So our final answer is 101 degrees. Measure of angle AXC would be 101 degrees. Now again in 14, you're going to want to make sure you have a diagram before you start. We've got given to us that the measure of angle CXD is 4x plus 6. Let's find that in our picture. That's CXD, so this angle here. Let's write in that's 4x plus 6. And then back to our instructions, we've got the measure of angle DXE, 3x plus 1. So DXE, here we find it. DXE is 3x plus 1. And then CXE's measure is 8x minus 2. CXE, that's the whole thing again. Let's write that whole arc all the way around to here, is 8x minus 2. And we're asked to find angle DXE. So I want to kind of highlight that so I can remember. Angle DXE is our question. What is this angle right here? Well, we can see that we've got two smaller angles that have been joined together. They're adjacent to make a bigger angle. So let's use our angle addition postulate and add those little pieces together. The two smaller ones are 4x plus 6 and 3x plus 1. Like I said, we're going to add those together, and that total is our bigger angle in green, or 8x minus 2. So we're set up for our algebra. First of all, we're going to combine those like terms. We've got 4x and 3x making a total of 7x, and 6 added with the 1 gives me 7, and everything else is just going to come down on the other side. Now, since most of our x's are on that 8x side, let's keep them there. Let's come to the other side and take away 7x's so they will cancel. Do it to both sides. And let's cancel those 7x's, and let's total these up to just make 1x. On the same line, I'm going to take care of the 2, the negative 2, so I'm going to add that in order to make that 0 out or cancel on both sides. So here we get to cancel the 2's, and on this side we get a total of 9. So our x value is 9. What was the question again? We reminded ourselves right here, we've got to find out this angle DXE. So angle DXE would be found by doing our substitution. We were told that it was 3x plus 1, so let's take 3. Let's plug in our 9 for x plus 1. 3 times 9 is 27. 1 more makes 28. So that's a 28-degree angle. And that's all there is to that one. All right, our last two questions, 15 and 16. We're classifying these angles as acute, right, or obtuse. Starting us off in question 15, we have angle WQY, which I want to highlight or trace that over. WQY, or this angle What kind of angle is that? Well, I noticed that it goes beyond the 90-degree mark, so it's bigger than 90. We're going to say it's obtuse. And then question 16 is angle YQZ. Angle YQZ, let's highlight that one. Hey, look at this. We have a linear pair with the angles in 15 and 16, but what kind is this? That one's short or smaller than 90 degrees, so this one's going to be acute.